This is again the ds-incubator on the series about exploring data with the tidyverse. And today we're going to be talking about covariation, that is the idea of two variables that vary in a related way, or the values of two variables that change in a related way. Today we're going to focus on one categorical variable and one continuous variable because depending on the type of variables that you have, you will need different tools to explore that relationship. In addition to the main focus of the meetup, which is at the conceptual level, exploring that covariation, we'll also be exploring a couple of tricks to make the code a little bit more readable. It's very subjective, and maybe you will, not agree with the approaches I'm showing here, but it's just one way to show some tricks about ggplot2. So beyond the conceptual level, to open a conversation at the technical level and the coding style that you might want to consider. So the objectives are then to explore the visual relationship, or explore the relationship between one categorical variable and one continuous variable visually. And then, because we have been using ggplot2 already quite a bit, there are a couple of arguments that are repeated time and again. And after some time, they become kind of noise. So we can remove those explicit calls to the arguments and still not degrade the understanding of the code. And by removing that noise, maybe now you're left with code that is clearer and that highlights more obviously the pieces that you are interested in highlighting as someone who writes the code. So that's one of the techniques that I'm going to be discussing today. Some people prefer to always use explicit arguments, but I don't. Sometimes I prefer to not do that, precisely so that what remains written in code is more obvious and the noise is away. And then I'm going to be also showing how you can save ggplot2 elements in variables, and maybe in another meetup we're going to explore the idea of doing the same in functions. But pretty much anything in ggplot2 can be stored in some kind of R object and reused as you want. So let's go to the materials of today. As usual, we are going to be using the tidyverse. I already mentioned a little bit of an overview of what that is. Is that tendency of two or more variables to vary together in a related way. And visualizing the relationship is one very powerful tool to explore that relationship. And as I said before, how you do that depends on the type of variables that you have. And today we're going to be talking about one categorical and one continuous variable. So the data set we've been working with is again the star of the show today. We're going to be using another data set too for a comparison, but mostly the Diamonds data set that comes from the ggplot2 package. And here are two variables. One is cat, which is a categorical variable. You can see that it can take only a few limited number of values, for example, ideal, premium, good. So there is no clear continuous way to represent the values of that variable. However, there is an order implicit in those values, and we're going to be talking about that a bit later. Then the other variable is continuous. Here is an integer, so it's not like truly continuous. It could also be converted into a real number, something that can take decimal digits. But because the price in this particular data set does not have decimals, then an integer is just fine, and we're gonna just take it as a continuous variable. So this is the relationship we're gonna be exploring, mostly cat versus price. So how the price varies with the quality of a diamond, because cat, that is what that variable holds. So let me go back to my R studio here, because sometimes I speak a bit too fast, and the idea of degrading the code that I'm showing helps me slow down a little bit. So we start as usual loading the tidyverse, because that is the set of packages that we're going to be using to explore data today. So here we are running tidyverse, library tidyverse on the console. And then the very first thing that you saw on my notes was this analytical way to have a quick glimpse to the data, in particular selecting the cat and price columns using dplyr the select function comes from dplyr, you might remember. Then there is, this is the explicit way in which we have, let me show you here on the right actually, maybe that is something better to be shown here. So we have been so far using explicit arguments like data equals diamonds or mapping equals blah blah blah. So that data and that mapping are arguments that are repeated time and again in every single ggplot2 plot, and thus after a while your eyes learn to kind of remove them, so you just focus on diamonds. But then if you are able to do that, then why do you even have data and mapping? It becomes so common that it becomes noise, and you can write the same thing a bit more compactly like this, removing the data equal explicit call to the argument, and here we are removing the mapping equal. The code does exactly the same, just that there is a bit less noise and it is more clear what's important here. What's important is that we are using the diamonds data set and the columns price and cut. So note that this time we are not using the variable y, because the frequency plot what does it automatically creates a y variable that comes from counting the number of observations of the values in the variable x, in this case price. So what we get here is that frequency plot showing for every different kind of cut, for every different value of cut, a different color. So that's why we get a reference here to the right, and that's a very common feature of ggplot2. That is very, very, very nice, that you can map different unique values of one variable to different colors or to different densities, for example, different opacities, or a number of options that you have to represent the data very compactly in the single coordinate system x and y. You can see many relationships. So this is the count of the different prices that we see for different qualities of diamonds, right? But note that this is not very informative. Why? Because there is a huge difference in the amount of observations that we have for diamonds of different quality. For example, at the very top here we have in yellow the diamonds of ideal cut, and we have observations of the orders of 6,000, for example. That's the around the maximum value count that we get from there. But then for fair diamonds we have a lot fewer observations, so it is kind of hard to spot the relationship between these curves. Remember that the whole goal today is to explore how these two variables relate to each other, cut and price. So we can't see that in this plot very well, because for example the fair diamonds are so compressed in the lower part of the curve. So instead we should probably do what CJ suggested in the last meetup, which is this idea of standardizing every curve so that the area behind the curve is always 1. So if we do that, then we get a plot that looks a lot different, and that makes the relationship, makes the comparison a lot easier. So how you do that? Well, the trick here is to not use just the count, but instead use as a y. So the y variable of the frequency polygon by default was count, right? So when we did not use an explicit call to the y argument in the plot above, let me show you one here, right? Here we didn't use y. So automatically what we got is the count of observations for the different prices by cut. But now that we are calling y, we can choose what kind of statistical representation or statistical summary of data we want to create. So there is this weird syntax dot density. It's weird, it is what it is. That's how ggplot2 understands what kind of statistics you want for the y variable. So dot density, is something that you learn just from reading the documentation. Will plot not the default count, but instead the density. So that is a lot more useful here, and we can see how the trend is very similar for just about every single diamond of different cuts. But note that there is a weird pattern here. So this is the kind of thing that we could be looking for, right? So this is why I thought like this is useful, because now we see, okay, there is a very general trend that all diamonds have a similar trend, but then there is something odd going on here that we are going to try understand in a moment. But let me go back to your pretty faces. I hear a hand or something. Anyone has a comment? Lovely, thank you, Anne. So efficient. Right. So the surprising fact that we can learn from thinking about this hump here in the curve. So know that these are fair diamonds, which are the ones that are of lower quality. It's kind of odd that the scale here, the reference is going kind of in the I don't know, it's going like from fair to ideal as opposed to ideal to fair. I don't know if that makes sense or not. But the point is that fair is worse than good, good is worse than very good is worse than premium, and premium is worse than ideal. And here we see that there are, at this level of price, we have diamonds of fair quality that are more expensive than other diamonds of better quality. So that's the surprising fact, that we have fair, the lowest quality diamonds seem to have the highest average price. So that is an odd fact, something that deserves exploring. I haven't gave it a lot of thought, but I know that in the book that it inspires this series, there is a section for questions, and the questions nudge you to explore the relationship between every single variable against cut, and that will lead you to identify that there is some other variable that explains the price better than quality. So if you are interested in trying to understand why this is the case, I do not have the answer, but I think you could go to the book, read the questions for this chapter and do what the questions suggest, and maybe you will find out what's going on here. So this was one way of representing the relationship between a continuous variable and a categorical variable, but there is other ways. A very good way is a box plot, and I really like this explanation, this visual explanation of a box plot, because look how we see what the actual values in the distribution could be, how they could be mapped on on a line, but then how those values would be represented if instead of just plotting them on a single line in one dimension, we plotted them in 2 dimensions as a histogram. So we see like a lot more values here, so the count is higher, so a histogram would show these taller bars. So this is a histogram but now flipped 90 degrees, right? And then a more summarized way to represent the same thing would be a box plot, right? So I really like this explanation. So basically, a box plot is just a little box that goes from the 75th percentile mark of the distribution to the 25th percentile. It shows very prominently the 50th percentile. Basically, the median values are very prominently displayed, right? So this is the median, and then the box gives us an idea of the bulk of the distribution, where it is in the interquartile range, and then we have these long whiskers going up and down all the way to the last point that is not considered an outlier. So this gives us an idea of the spread of the distribution that is not an outlier. And then we have, because outliers are so odd, we want them, and because they are few, that's kind of the definition of an outlier too, it's the few values that go beyond the most common pattern, then it's easy to plot them independently. So here we see 2 outliers that go beyond the 1.5 times the interquartile range, which is the definition of an outlier as per the definition of box plot. So beautiful statistical summary in a visual way. That's what a box plot is, if we know how to interpret it. And if you ever forget, then you can come back to this figure because I find it super succinct and clear. So how you plot a box plot? Well, there is the function geom box plot. Remember that geoms were geometric representations of the data. So usually, every single time you have a function called geom underscore something, and in this case what we want is a box plot, so that's what we get. So the same two variables, diamonds and is the data set, and the same two variables, cat and price, but this time not using a frequency plot, but instead a box plot. Notice something that is different from the plots before. Before the call to AS, so the mappings, many times we called it inside the geom function, and it's both functions, any geom or the ggplot function, they both have that argument called mappings, so meaning that you can do this call to AS wherever you want, at the ggplot function or inside the geom. What is the difference? Well, the difference is that by defining the aesthetic representation of the data in the call to ggplot, then that applies to every single layer, so every single geom that you might use. So in this case, you are using just one, but you could overlay one layer on top of the other. You could call geom something multiple times. And in each one, you could create a different mapping for X and Y variables. So in this case, because you are calling it at the very top level, at the level of the ggplot function, that representation will apply by default in all other layers, unless you overwrite it at the level of a specific layer. Maybe that was a bit of a mouthful. Don't worry too much for now. For now, maybe it's enough to know that you can call it wherever you want, at the level of ggplot2, or at the level of ggplot, or at the level of the geom. And I know that we are 20 past. I think we don't have too much more to cover. 3 minutes, perfect. So let's push through, because I'm pretty sure I can finish this in 5 minutes and leave 5 minutes for comments and questions. So note that something very interesting is happening in this box plot. So first, this box plot seems to confirm the old observation that we made before, that fair diamonds seem to have a mean price that is higher than the price of any other diamond, or diamonds of better quality. So that's weird. That's why very quickly visual representation can point us in an interesting direction, asking for clarification to the data. So that's one thing that we can get from here. And then one other observation I would like you to do is that how the plot automatically ordered the diamonds in the sensible way, from fair to ideal, in an order manner, right? Fair, good, very good, premium, ideal. And that is because cat is in the data set already represented as a specific type of variable, which is called a factor, and it is ordered. So it is a very special flavor of a variable. So if we call the variable, the function distinct, coming from dplyr, and then we pull the values of cat, we can see that cat has these levels. It can be ideal, premium, good, very good, and fair, and the levels are ordered. Here you see that fair, good, very good, premium, and ideal have an order. Being ideal, the one that is greater than anything else, right? But now, what would be the world look like if we work with a not ordered variable? So for that, we don't have a good example in the diamonds dataset, so we're gonna resource to the MPG dataset that also comes from ggplot2. So here, if we do the same thing, so say there is a variable called class. So if we pull the values of class, you will see that it's not ordered. It's just a bunch of strings, right? That don't have any implicit order. And now I'm gonna show you one other trick. Thank you. So I'm going to show you this one other trick, that is the idea that you can store in a variable just about almost every object of ggplot2, you can store it in a variable. So remember that either inside ggplot or inside the geom functions, you can, you have to call the mappings. So you have to say, to call the function AES with, values such as, the X and Y, what variables you want in X and Y. So here I'm doing it outside the ggplot2 function to show you that you can do that if you want it. And I do it just for clarity because I want to show this as a very obvious element that is going to change between this plot that I'm going to show you now and the one that I'm going to show you later. So I'm storing the class and highway variables or the aesthetic representation of those variables in an object that I call class underscore highway. And then if I just print that object, here you can see what it looks like. Nice, nice. Thanks a lot, and thanks a lot. I think we're good. I'm gonna go for a couple more minutes and then open the room for questions and comments. So if I print the class underscore highway object, see that it is, it prints in a relatively clear way. So it's just a representation of what those variables, how those variables are related, but it's not doing anything. It's not throwing an error and it's not plotting anything. It just holds information. Then it's kind of metadata, right? So then we can pass that variable inside the geom function, and it will work just as if we had called the AES function inside the geom boxplot function anyway. So this is to show you that if we plot the class and highway, so highways is, by the way, so the MPG dataset contains information about cars, as the names here in the x-axis suggest. And what HWY holds is the miles per gallon that you get when you use that car on a highway. So note that if we do a box plot with those two variables, there is no clear order here. Everything, there's no kind of clear pattern. Some boxes are below, others are at the top, blah, 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 right? So we might want to order this a little bit so that it is easier to see what's the pattern. And one way to do that is to use the function reorder of the dplyr package. That's beautiful. So that function takes the variable that you want to order. So in this case, it's class. So these are the classes of cars that are kind of all messed up. So we would like to order them. And how would you like to order them? Well, we can order them by the values of a highway using the median of the value of a highway. So the median miles per gallon that you get for each class. So this is what this call to reorder is doing. So now my aesthetic does not just pass the class variable to the x-axis, instead passes the reorder class, reordered by the highway variable, or by the median values of the highway variable. So that's why I call this class reordered by median highway. So if we now pass that to ggplot, to the geom box plot, then you can see that the plot, plots the same thing, but in an ordered way. So it's kind of clear to see, for example, that, like a pickup car gives you less miles per gallon when you drive that car on a highway than a mid-sized car or a compact car. So it's very, 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 very clear, and you can see just by reading the x-axis, which car you might want to buy if you want to save fuel, for example. You would go here to the right. It's easier to spot. And then when the names are long, this is not the case because all these names fit in the XY axis. But when the names are long, they start to overlap. So the word, for example, subcompact may overlap with compact. And then what you can do is just flip the plot with chord flip. Remember last meetup we used the chord Cartesian function, I think, to change the limits of the y or the x-axis, and this time we are using a friend of that function that is called chord flip to flip the coordinate system, so that now what was the y is no longer vertical but it's horizontal, and the x is no longer horizontal but it's vertical. So yeah, that's all I wanted to show you today. That leaves us a few minutes for comments and questions, discussions. So if you have some, go ahead. I hope you like the background music today. Yeah. So we have CJ now. I'm not sure if he was in the section where we showed CJ. We covered the density plot. I think. Cool. Yeah, that was. I guess the comment was offset by one meetup. I didn't know we would cover this today, but comes at a great time, because it's almost like a compliment to your question or to your comment suggestion last time. Really nice, because I didn't have in my head kind of the formal definition of what a density plot is, and now I have it. So the idea of it is the count but standardized so that the area under the curve is always 1, and I think that's very, very clear. Yeah. What was there was a box plot. Ah, here, yeah. B. Like a bee. Ah, bee, and then swarm. Blood, teacher blood. Nice. I see. Yeah, absolutely. Thanks. I see here Bingy. Need to go. Okay, cool. I guess that's all we have for today. Thanks for joining and see you next time. Ciao, ciao.